Right, 2.3 additional displays of quantitative data. So there are many ways that we can display quantitative data. We looked at some there in 2.2. So here we're going to continue looking in 2.3. All right, so our first objective, draw stem and leaf plots. So the stem and leaf plot is just another way to represent our data. We have the stem, which is the digit to the rightmost, and then each to the left of the rightmost, and each rightmost digit forms a leaf. Okay, so let's look at what that means. So, for example, we have 147. 14 would be the stem, 7 is the leaf. So whatever our rightmost digit, the last digit to the right there, in the ones place, will always be our leaf. Now, if we have a decimal, it's going to be whatever the last one is, so it wouldn't be the ones place in that case. And we'll look at some of those, all right? All right, so here, let's look at this table. And so we have all these decimals, so 16.9 and so forth. We're looking at persons living in poverty per each state on those, okay? So the number after the decimal in the tenths place will be our leaf in this case, and our whole numbers will be the stems. So we create that. So for instance, the stem for Alabama is 16 and the leaf is 9, and so forth, okay? So we would start there. We have anything ranging from 7.7 to 19.8, and so our stems need to range from 7 to 19. All right, so here we put in our leaves then, so any of those decimals that would go on the other side, and we just line them all up. So for instance there, the first one is 7.7. Now there were none in the 8s, that's why it's blank. But in 9s, we had 9.6, 9.5, 9.3, 9.5, 9.7. And we would follow that all the way down, continuing that. Okay, so that's how we would construct a stem and leaf. Now, we would also want to probably rearrange those things in order when we look at our numbers. Technically, we don't have to, but we like to do it that way because we like things in numerical order. So we would do those pieces and be easier to see. All right, so when we're constructing our stem and leaf, we look at our digits, we find the rightmost, and that's going to be our leaf, and then everything else is going to be our stems, and we're going to write those down. Okay? And then we put them in order. All right, so we talked about those. All right, so that was, sorry, I was looking over that. That was just some stuff obtained from doing it in Minitab. So there are many different programs you'll see pop up here. I'm going to focus in on the calculator when that time comes, but for right now we don't need that. But you can do some of these things in Excel, StatCrunch, Minitab. There are many different programs that do some of these statistics, but we're going to focus in on the calculator when it needs to come. Okay. All right. Now the good thing about stem and leaf is that once that we do a histogram, we can't see the raw data. Whereas in stem and leaf, we can see the raw data. We still know what numbers went with those specifically. All right, now we can also do a split stem and leaf plot, okay? So we can see here, looking at this data, that we have a bunch of 1s and a bunch of 2s with us. So we can actually break those apart and look at, 1 to 5 and then 5 to 9 on those. And so we broke apart the 1 into 2 groups, the 2s into 2 groups, 3s, and so forth, so that we can see a little bit closer, so that we don't have things running off our page on those. Okay. Frequency polygons. All right, so a frequency polygon, first we need to know about the class midpoint. All right, and so that is the sum of our lower class limits divided by 2. Okay, and so we need to find the middle there of our class is what we're doing. Now, frequency polygon uses points, and those points will be our midpoints, and we're going to connect those with line segments. All right, so here we have our information, so we need to find our midpoint. So we can see on these that we have here Let me get my marker. So we took 50 and 75. We add those together and divide by 2 to find the midpoint of 62.5. Then we take 75 and 100 and add them together, divide by 2, and then we continue to do that, each one of those. And then the next ones and so forth, all the way down. Now we do have to be careful here. We know that even though it's not listed, that this last one down here at the bottom, it is going to be 325 because it's the next number up from 324. Okay, so make sure you're aware of what that number is. Okay. All right. Now, if we were to put those midpoints on there, we could then put them together, and this is what our frequency polygon would look like on those. Okay. So notice all those numbers are just the midpoints of all of those previous charts there. Okay. All right, cumulative frequency and relative frequency tables. Now, cumulative means that we add them together. Anything previous, we add on to it. So instead of separating things out, we need to add up with those, okay, for those. And the same thing for relative frequency, okay? All right, so what we'll notice on those is how we add things. So we always start in the same place. So you'll see here that our first frequency and this frequency are the same. But to get to the next one, we're going to take these two and add them. Or actually, it's, let me take that off. It's actually here going to be this plus this one. That's where we get our 1. And then we're going to take our 1 plus 7, and that's where the 8 comes from. Okay, and then we do 8 plus 10 gives us the 18, and we will work our way down for that. So each time, that's how we would come up with those. Well, then we would do the same thing over here for our relative frequency. So we take our 0.2 plus 0 gives us the 0.2. 0.2 plus 0.14 gives us the 0.16, and so forth, to create that cumulative amount. Now, one of the things that you'll always find on a cumulative is that whatever our total amount is, should always end up here. There were 50 items in our frequency, so this should always be 50. Over here, this number should always be 1 every single time because it's our cumulative relative frequency, and the frequency should always add up to 1 on those. So if you come up with different numbers there on those, if this 50 doesn't match the total in the frequency, you've done something wrong. If the cumulative relative frequency doesn't become 1, you've done something wrong. Okay. All right, now in ogive, this is just the graph that represents the cumulative frequency. So they made this special name. I don't know where it came from. At least they put the pronunciation, because I would probably pronounce that wrong. But it just is the graph that represents cumulative frequency. So when they ask for an ogive, that's what you're going to do there. So here we did just that, taking our relative frequencies and creating our graph with that. Okay. All right, time series, that just means that we are looking at time. All of our data is dealing with time, and so we call that a time series. And so when we plot that, same thing, okay? So here we have years, 2005 to 2018. We're looking at this PCI here and what it is. And so we have that representation. So when we put that on our chart, this is a time series plot because we're talking about years and what it is during that year. Okay? All right. So those are the things that you're going to need to know for 2.3.